All right, everyone. I think I'll get started in a moment or two, just as soon as I get the okay from the AV team. Yes, I do look that bad. You can't do anything about that. All right. So I have plenty of time for this talk, so I'm going to try and go through it at a nice, even pace. I do tend to get a little bit excited about these technical things, so I might speed up, but you might have to slow me down. Please feel free to ask questions throughout the talk, and make sure you remember to ask me to repeat them for the recording and for everyone else in the room. My name is Clinton. I'm from Australia. I'm a software engineer there. This talk is not just about the language or one tool, but it's an interesting sort of talk about how different languages compete in a little bit of an ecosphere and what they learn from each other and how they learn from each other. So we're going to look at packaging and where Python is now and how easy or hard it is to package things now. I want to look at some of the improvements that are being made to Python so that in the future it gets easier to package things with standard Python. I'm going to look at a particular tool that I think embodies a lot of the ideas about where Python packaging could be in a few years' time. And I want to take a quick look at how some people are already taking poetry and moving beyond it. Nearly all of my slides are about things that you can and should be doing. I've got one sort of ranty slide right at the end about what you shouldn't be doing. I've tried to push all of that into just one slide. So let us begin. So when you're doing a talk about the Python packaging ecosystem, it's almost obligatory to use this XKCD comic. It's a few years old. There's some Mac-specific stuff in there that totally goes over my head. I work for an Australian government site. No, I shouldn't use site. I work for an Australian government organisation that actually deals with nuclear energy and nuclear waste. So when they talk about a Superfund site, that is an American-specific term for an area that is so heavily polluted that it could endanger people's lives or the environment. If your computer Python setup is bad enough to infect the environment, that's very bad, but I hope it doesn't get there. But if your environment is bad enough to actually be affecting your health or your mental state, close it and move away. It's a technical problem. You shouldn't let that sort of transpose into a mental problem. If you are getting angry and aggravated about things, you need to find an appropriate outlet for that. A comic might be an appropriate outlet for that. So right now, if you're developing a typical Python package, you are hopefully using virtual environments. One of the things that I do is I teach Python to beginners. A lot of these people are professionals in their particular fields, but they're not programmers or developers. So trying to teach the idea of virtual environments to people and exactly what they are and what they can do and why you should be using them is kind of hard. You've just taught them what a variable is with like either the spreadsheet analogy or the shoebox analogy, and now you're trying to teach them what a virtual environment is. It's a little bit much. But it's also the first thing that we tell them all to do because it'll save pain further on. We should be making this easier. Setup.py is the canonical name of a script that handles your packages for you. Most people don't know how to write them. Most people know how to Google for the particular issue they're having and copying and pasting a code snippet into their setup.py, and it looks like it solves their problem. It may well be creating more problems for people further down the road, but that's not something that you can see. A very common thing is requirements.txt. So this is also known as like a lock file. So it will have a list of all of your dependencies and a particular locked versions of those. This is becoming very common with a lot of other different programming languages, and it's something that Python doesn't have a standardized approach for yet, but I think we're going to see that coming. And something that Python also has is a centralized packaging index with PyPI. Now, what are the issues with this? Well, this is a blank slide, so clearly there are no issues. So what are the issues with virtual environments? Virtual environments don't particularly handle the problem that we've currently got, where you're dealing with 2 or 3 or however many versions of Python you've got to deal with. They don't stop you from doing that, but they don't make it any easier. And as I alluded to before, they can be difficult to teach because they're sort of like a virtual directory, they're sort of like a virtual environment, they're sort of like a container, but they're not really. And one of the things that I'm constantly coming across with when I'm teaching people programming is you've got to remember to activate the virtual environment with every new window that you open up. So your typical thing, you are making a server and a client, you want to activate 2 windows, and you've got to explain to them that they've got to activate the virtual environment in both. And it's very confusing. And what are some of the issues with setup.py? It's code. It's not a configuration file. That's the chief problem. In order to figure out what you need to build a random package, you need to run the setup.py. So if you're on a server farm trying to build a Python package, you've got to run someone else's code to figure out if you can build it or not. There's all sorts of issues with that. It makes dealing with these things at scale really, really hard. And by at scale, I mean more than 5. And I don't mean any of this to denigrate the work that's being done at all. This is how projects, particularly in the open source world, go forward. None of these things are wrong. They happened at a certain point in time. And now when we're looking back, we can see the carnage that we've accidentally left behind. A lot of decisions were made in the process of getting to where we are with PyPI and setup.py that it's very difficult to change now. There's a lot of organic decisions that were perfectly acceptable at the time, but now that we're trying to solve bigger and bigger problems, they're not so good. And the other side of the coin is that there are a lot of decisions that are not actually written down anywhere except in the code. And if they're only documented in the code, it makes it really hard to think about these things. And what we have started to see, and this is not a bad thing, but what we have started to see is lots of tools springing up into existence to try and solve some of these problems, to make life easier. So there are lots of tools to try and replace setup.py so that you're not having to copy and paste other people's setup.pys, and you can configure your project so that it builds and ships properly. The problem with that is that it's very hard to, when you're teaching someone Python, it's very hard to go and say, use this tool, because it is the tool that will fix all of your problems, because there is no such tool. And also, you don't want to point at a tool that is actually not part of the standard Python environment. So trying to step back a little bit and have a look at the ecosystem as a whole, a lot of the Python core developers are looking at modernizing, excellent, that's my new word for the day, are trying to modernize the build and publishing tools of Python. There are a lot of PEPs, that is a Python enhancement protocol. It's like a request for comments document for the internet. The PEP procedure is that you write a document, you get a lot of people to talk about it, and then they sort of provisionally agree that they think it's a good idea. They say that it's a standard, and then they try working with it for a couple of years, and if everyone essentially agrees, then it says, yes, that's good. But there's a lot of PEPs in the last few years that are trying to learn from some of the decisions that have been made in the past and fix these problems in a different way. From a little bit closer, that means that the Python core developers are trying to pick formats, APIs, file standards, file formats, so that all of the different tools that form part of the packaging ecosystem can talk to each other without having to actually pick and anoint particular tools, saying this is the build tool that you must use, this is the packaging tool you must use, this is the publishing tool that you must use. So the PEP that a lot of this stuff is sort of based around is PEP 517, and that defines a source tree file format. And one of the things that they're trying to, the two things that they're trying to fix in that one is that if you are given a Python source package and you want to build it, you have to open it up and run the setup.py to figure out what packages you need to build it. And then you get to download those dependencies and then run setup.py again. And because it's code, it's quite possible that the first time you run that setup.py, it'll fail on the first dependency. You install that dependency, and then it will fail on the second dependency, and it just keeps on going. It's not, you don't want to have to try and configure your build environment by running code. You want to be able to get a configuration file that says, this package depends on these 5 things. Right, I'll go and install those things, and then I'll run this script, and it'll build it. The other thing that it's trying to do is have a sensible way for packages to be able to look up their own version. This is one of the things that kills me quite commonly, is that it's actually, there's no nice standard way for a Python package to know its own version. You've actually got to jump through hoops, but they're trying to look into ways of fixing it in the future. And things have happened a few times now where they've made advancements, particularly in the PyPI world, and they've accidentally broken some backwards compatibility stuff, so they've withdrawn that change and decided that was the wrong way, we'll take another tack. So with my nose up against the glass, looking at the details, the two things that I'm going to look at that I think are really positive steps forward is a new way to configure builds in a non-imperative way, so a configuration format to describe everything that you need for your build. And something that I think, if it's accepted going forward, will provide us with a much easier way of having virtual environments without us having to do anything, without us having to teach them. And as a teacher, that's definitely a good thing. So, proposed in PEP 518, specifying a minimum build system requirements for Python projects, it is a new file called pyproject.toml, and we'll go into the format of that a little bit in the future. But the nice thing with the particular file format that they've chosen is that it's not just for building Python projects. Any tools that you have that need configuration, with very few exemptions from that, they can also use the PyProject configuration file to put their own configuration in. So you can configure your build tools, your code linters, your testing tools, all in the one configuration file. So in, let's say, a decade's time, when you check out a Python project, instead of you having 14 different configuration files for all of the tools that you use, they'll all be in the pyproject.toml file. So that initial checkout, you won't have a little bit of a gasp of what you're looking at. It's a new format, but it also looks very similar to the ini file format, but its structure is very much more closely aligned with the JSON format, and it is nicely standard. It is nicely standardized, unlike the ini file format. So here we've got a very simple TOML file showing a library with 2 books, and we've got the identical representation of that data in the JSON file format next to it. So you can see the TOML on the left. It looks very much like an ini file, but it contains the same structure as the JSON on the right. So the main difference between ini and TOML, at least just from looking at it, is that TOML has a lot more defined data formats. So it can handle integers and floats and date times and lists and dictionaries. And because JSON doesn't handle those, I haven't got those examples there. But the other nice thing is where we've got those book objects there, we're just repeating a book object. And all we're actually doing is appending to the book table. And where that gets used in our world is that if we depend on multiple packages, we can just have another package section describing the name of the package and the version of the package that we want. So the configuration that's required for build time dependencies is actually quite simple and easy to read. And TOML is designed to be easy for regular people to edit. And JSON's good for machines, not so good for humans. One really cool PEP is PEP 582. I believe that's still in draft at the moment. The idea here is that there is a standard directory to have all of your packages installed in. So if you are building an application, in your top level directory, you have a under PyPackages directory. Underneath that, you have a directory for each Python version that you're depending on. So typically these days you'd have like a 2.7 and a 3.7, or if you have to keep up with me at work, that means a 3.8 alpha now. And underneath each of those directories, you have, it's a little bit wishy-washy at this stage, but underneath that somewhere, you have all of the libraries that you depend on. These local package directories are treated exactly the same as virtual environments, except that you don't activate them. So they're not very good for having scripts and stuff in them. However, if PyPackages gets added as a standard, any scripts that are in these local virtual environments will not be able to find out that they're in a local virtual environment and will work without you having to activate it. So that's a little bit of a rub at the moment, but for libraries, it's wonderful. For scripts, it needs a little bit of work. It's very similar to the node modules directory in JavaScript land, where every package gets installed locally. You never have to think about creating a virtual environment. It's in a known standard place. So the workflow for building a Python package, you lose the step about creating and activating a virtual environment. It just gets done for you. So this one is still going through the processes. It was still a draft the last time I looked, but I very much hope that that one gets rolled in. And there is already an implementation of it. And it's very simple, because all you're doing is shoving under PyPackages into the Python path before the system Python path. And everything else just works for you. So I've looked at two areas of Python where Python itself is taking advances to try and make building and maintaining packages a little bit easier. I want to look at a separate tool now called Poetry. This is still a pre-release project, so I think it was like 1.0 beta 8, I think, was the last I saw at it. So it's still not actually released yet. Unofficially, it's sort of one tool to do all of your packaging tasks. It will help you handle your project that you need to work on multiple versions of Python. It will build your package, it will install all of your dependencies, and it will help you publish your package up to PyPy or your company's internal PyPI, sorry. It's kind of similar to Rust's Cargo, if anyone's got experience with that. There's been a lot of really useful functionality just added in like the last 2 or 3 weeks. So it's still in the oven baking, so don't run home and change everything to use Poetry. One of the potential issues at the moment is that the community team, there's one head author, and there's a couple of guys that he's trusted with bug fixes. And he's got some fairly strident views about particular things, and that seems to be annoying a few potential users of his project, but that's open source. All right, this is a sight gag, so I'm not going to say anything. So because Poetry is a Python project, it has its own dependencies. Your project has its dependencies. Try and not install Poetry in the same virtual environment that you're installing your packages to. It'll just lead to heartache. There are a couple of nice ways of installing Poetry. I prefer installing it into my home users' local Python packages, so that I'm not having to go sudo pip anything. The approved method for installing Poetry is one of these really scary curl this package and then pipe it through to Python and it'll all be good. And I don't suggest that you actually do that. I tend to shy away from things like that. In the future, when we've got a local PyPackages directory, you'll be able to treat this like anything. You'll just be able to do a git checkout and do a pip build, and then you'll have Poetry. It is starting to show up in some Linux distros, but it's a pre-1.0 software, so you wouldn't expect it to be in many Linux distros yet. I haven't seen too many bugs about Mac. I have seen some Windows bugs. These are apparently standard Windows bugs that you get when you're trying to do reasonably boring things like deleting a file and discovering that you can't actually delete files in Windows. So I think that there are standard solutions to some of these problems, but because the main author's not a Windows guy, I think it's going to take a while to fix those particular issues. So this is not just a Poetry assumption. This is actually a generic sort of Python packaging assumption that a lot of the PyPI developers adhere to. Everything that you publish that is a library should be put into a wheel, and it should go up to a PyPI somewhere, be that the global PyPI or your company's PyPI. Anything that are applications almost certainly should not be published as a wheel, and they should be packaged by some other means. So if that means putting it into an executable installer, being put into a container, tarred up locally, installed in however many you like, that's how they want applications to be installed. They don't want applications to be installed via PyPI. Definitely a basic Poetry assumption is that one repository is one package. It does not handle monorepos, and that's a particular choice that Sebastian has chosen. But I will mention that in a further slide. So Poetry is a command line tool with a bunch of subcommands for doing things with projects and virtual environments. So you can create your project. You can manage virtual environments for all the different versions of Python that you want to support. You can maintain your project by adding and removing dependencies. You can develop your project by modifying versions. You can publish your project up to PyPI. I'm going to walk through the creation of a project. Poetry has an interactive form, and this will point out a lot of things that Poetry offers, I think. So the italic is the input, and then the little enter is me hitting enter. So this is the metadata for the package. So the name, the version, the description. I'm not quite sure where it's picked up that email address. We'll have to work that out in the future, because I definitely wouldn't be doing open source at work without having everyone's tick of approval. And you can see there the compatible Python version with the caret. Poetry introduces a couple of different ways of handling dependencies and having sort of squishy dependencies. So it's like, I'm happy for 3.7, but like 3.7, 1, 2, 3, and 4 are also okay. And I will go a little bit in depth on that in the future as well. And just a reminder, like any questions, anything's confusing, whack your hand up and make me repeat the question. So the next part of the Poetry install is, what dependencies do you want? I end up doing a lot of things that come around with parsing. So I install a few parsing libraries here. The interesting thing here is the number of different ways that Poetry lets you reference a dependency. Now these are all fairly standard, but a good 4 of these were only recently added. But you can now install or depend on a package that is in the public PI, is in a private PI, is in a GitHub repo somewhere, and that can be public or private, or in a path. So it does handle might not be the right word. It accepts that lots of people have sub-projects where they built wheels in, and you're building a super project out of that. So it now handles a lot of the standard ways that you would like to be able to reference external dependencies. I would like to make use of PyCparser, which is a Python front end to a yak-lek C parser. Because although most of my projects are Python-based, they're often not to do with Python. Here you are doing a search of PyPI by default. And for reasons that remain very confusing to me, there is a package called PyCparser, please ignore. No, I don't want that one. And I'm a little concerned about the fake libc one. I haven't looked at that one yet. I'm going to guess that that's some muzzle thing, mostly because I don't like muzzle. So here I've just requested the latest version, and it has given me the version that it's going to remember is caret 2.19, and I will explain the caret a little bit in future. And after I've interactively gone through the create process, Poetry creates the pyproject.toml file, and these are the keys that it's added. So these are more or less standardized keys. So build system is a standardized key that is referenced in one of the other PEPs. So in a slightly future world, when we hand this package off to PyPI and they want to build it, and like we give them the source package, they want to build a wheel, they will open up the package, have a look at this pyproject.toml file, look for the build system key, see that it requires Poetry, that server will install Poetry, and then they'll ask Poetry to run poetry.masonry.api to build the package. And then poetry.masonry.api will get past the same pyproject.toml file, and then it will parse the tool.poetry keys. So the idea there is that if you are comfortable using setup.py or flip or Poetry or something else that I haven't heard of yet, you can specify that in your pyproject.toml file, and the server that's going to build your package will be able to handle all of them. Poetry has, I'd said 3, and then I've got 4 dots there. That's the one bug in the entire set of slides, I promise. So if you want to depend on a particular version of a project, you use that particular version number. If you only care about the major and the minor version, you can use an asterisk there as a wildcard. The caret is its own favourite version, and that implements semantic versioning. Now, I won't be able to get into what semantic versioning is, but the idea of semantic versioning is the same idea that Unix guys had when they were writing C libraries 80 years ago now. It feels like 80 years. And the idea was that you only change the major numbers when you're actually changing functionality and it's not backwards compatible. That's all semantic versioning is. And the tilde versioning is a slightly looser version of the caret versioning. I don't want to get into the details here. The website for Poetry has a much better explanation than I'm going to be able to give. But basically, you are saying, with the caret versions, I need at least version 2.19, and if someone else releases 2.19.1, 2, 3, 4, feel free to use that as well. So we've created a Poetry project. Now we need to make a Python environment with a particular version of Python that we can do some stuff in. So the subcommand is env. The sub-command is use. So we are asking Poetry to use a Python 3.7 binary to make a virtual environment. And it's gone and made it underneath Poetry's cache directory there. Then I've gone in to ask Poetry to run a shell, so a bash, inside one of these environments. And inside that environment, I've asked bash to tell me which Python binary it's using, and you can see right down the bottom there that it's pointing to a version of Python that's inside that virtual environment. Yeah, and whenever you see virtual environment paths and they've got randomly allocated letters and stuff into them, trying to explain what that is to someone just starting out, it's just horrendous. And going forward, if we end up having our Py packages directory where you don't have to do any of this, that would be wonderful. So we've made our package, we've made our environment. Now we want to install all of our dependencies. So we go Poetry install. So this will install all of our dependencies, and in this case, it's only PyCparser is a dependency into the local environment. It will also install our package, which is called example, into the same virtual environment. And the thing that Poetry does really well, but doesn't really tell you about, is that it's working out dependencies of it's working out and resolving conflicts between not just your dependencies, but all the dependencies of your dependencies and dependencies and dependencies. So if you are making a Django project and you install Django, it will download like 30 odd packages, and those packages will depend on other packages than that. Poetry will look at the dependencies for all of those projects and make sure that the versions you have got will all work with each other, as declared in those separate projects. What pip will often do is install all of the dependencies that you specified, and if some of those dependencies happen to clash, yeah, you're gone. So after we've run some of these commands, one of the things that we'd like to do is have a script that we'd like to be able to run from our example project. So we make a change. So this is very similar to like an entry point in setup.py language. So we have a key in our pyproject.toml file called tool.poetry.scripts, and we call the script hello, and we give it a Python API point of example hello. We add a file to source example init, and I use the one true source code layout system with the source directory, and Poetry does support that with a little bit of wrangling. And I import this, and I have a hello. So that means that when I go Poetry run hello, it will import the hello module and run the hello function inside of that. And when I run that, my hello function says Kia ora and tells me what version of Python it's using, and you can see it's running from the same version of Python inside the virtual environment. And then it tells me what the source code of the file that hello was defined in. Now, the interesting point to note here is that that example init file is not in the virtual environment. So what's happened is that all the dependencies have been installed appropriately in the virtual environment, but our project has been installed in develop mode. So I can edit the source code of example as much as I like without having to, every time I make a change, reinstall that package. So the thing that you do for applications is applications tend to have lots and lots of dependencies because you're pulling in frameworks and libraries and they're pulling in their own dependencies, and it's quite often that a big application, you'll end up having like 100 dependencies. The thing that you don't want to have happen is if you're working in a team or you're working at home and at work, what you don't want to have happen is the two environments at work and at home are slightly different. You've ended up installing slightly different versions of things and you get a bug that's introduced. You really don't want that to happen. So when you have done a Poetry install and it has downloaded all of your dependencies, one of the files that it generates is a poetry.lock file. And what this has done is it will list all of the packages that that Poetry hasn't installed, and it pins the version numbers. So in the two different spots at work and home, you can install exactly the same version of dependencies, meaning that you'll have exactly the same behavior. And one of the other things here is that it will actually do a hash on the version of Python that you've got, so that if you modify the virtual environment, it will realize something hinky is up. And it will also hash the pyproject.file. So if you change the pyproject.file and add a new dependency, it will realize that and tell you that you need to upgrade your local setup. So I need to go back to the Poetry and Python assumption that when you're making an application, you have done a install, so you've installed all of the dependencies. Poetry has created a poetry.lock. If you're writing an application, the suggestion is that you add poetry.lock to your source repository and commit it. So then when you do a checkout at home, part of your checkout is poetry.lock, so it's got particular versions of your dependencies, and when you do a poetry.install, Poetry will see that lock file, and rather than work out what the latest and greatest versions of everything is, it will install exactly the same version at home as you did at work. So that's where the differences lie there.
Sorry, could you just go into that in just like a little bit more detail? Because it's something that I run quite regularly.
So quite a few different tools have a lock file. And the idea there is that you want to recreate your development environment in two different places. So it could be work and home, or it could be a couple of co-workers. The first person that generates the poetry.lock file, or the pip lock file, they commit that to source code, and it becomes tracked. And after that, everyone who does a checkout of the same project and does like a Poetry install, everybody will get the same version of the software installed. So the idea there is so that you're not chasing down squirrely little bugs because some sub-dependency has a different version. Is that 1 minute or is that 10 minutes for talking? 1 minute? Ah. I thought I had a lot of time. So you can search for packages. You can add and remove packages in a fairly similar way. And that's showing some of the differences that happen in the project. You can bump the version of your project using tools inside of Poetry, so you don't have to understand semantic versioning yourself. The Poetry tool will handle it for you. You can build your wheels, you can build your source distributions with it, and you can push your packages. That's standard stuff. That's not so standard stuff. Firefox has a big problem. They have a lot of Python 2 code that they're trying to move to Python 3. They have written a thing called Jetty, which wraps Poetry, and they have a monorepo. So if you're interested in monorepo development with Poetry, Jetty might be something to look at. This is new technology. It's not fully baked. Have a go at it, but do it in a reversible way. Use environment markers in your setup.py. Don't use code. This is my ranty slide, so this is my fun bit of slide. If you're putting a bug up against Poetry, your use case is special. It's not common, so stop pretending that your use case is great and everyone else is broken. If you put a bug report into Poetry and you're trying to say, my big enterprise needs this bug fixed right now, if you're working for a big enterprise, you can afford to pay for someone to fix this bug. Why is your big enterprise more important than a smaller company or a hobbyist who's working on this stuff? I don't remember signing that as a contract for working on open source stuff. And a big enterprise probably shouldn't be deploying pre-1.0 software anyway. Be patient. Have a look at the age of other pull requests. There are only a few authors accepting pull requests, so no one is treating you poorly just because your pull request hasn't been looked at for a week. So I would definitely just like to say thank you to everyone who's working on the Python ecosystem, all the people who've worked at the PEPs, all the people who've worked on PyPI, all the people who've worked on setup.py and all the other projects over the years. Thank you very much.